Okay, in this screencast, we're going to go over the important procedure of recoding a variable so that we can use it with our analysis. And as you can see, I've got an SPSS data set open up in front of me. And this particular data set is a 2008 survey that looked at attitudes towards women as leaders. And it has one question in particular that I'm very interested in, which is, generally speaking, do you think that men make better political leaders than women, that women are better political leaders, or that they are equally good at leadership? And what I'm interested in trying to determine as a research question is why it is that some Americans are prejudiced against women American leaders while others are not. And so in order to begin my analysis, I'm going to have to look at what questions, if any, address my particular question. Now, I downloaded this particular data set and questionnaire, so I know that it's in here. And so I've got my Word document open, and I'm going to take a quick look at seeing if I can find that question. And sure enough, there it is, question 10. And what I'm going to do is right out of the Pew questionnaire, I'm going to copy that, and I'm going to use that in my particular data analysis. Now, one of the things that we've talked about a little bit on these screencasts is the importance of using screencasts, or screencasts, the importance of using your syntax file. And so right off the bat, I'm going to define my main dependent variable, which in this case is people who support men. And so I'm going to make a notation to myself, and because I don't want SPSS to run the notations I'm making, it won't allow it to do it. I'm going to put a little asterisk here. I could have also just poked on this, and I'm going to make a note to myself about what I'm doing. Dependent variable. Think men are better leaders. And now, to make sure that I don't have any coding mistakes, and also when I'm writing up my work, to make sure that I correctly say what it is that the particular survey item in the Pew survey asked, I'm going to go ahead and paste it right in. And again, because I'm right directly underneath this, it's going to go ahead and gray it out, meaning that SPSS won't read it. Alternatively, I could have just selected it up here, and it would have created the same general issue. So now I'm ready to recode. As I'm in student mode, I can't remember what in the heck the language is for that. And so I'm going to go ahead and let SPSS do some work for me, but not do all of the work. Because I'm going to create a new variable using this as a basis so I don't mess around with it, I'm going to end up going up to transform. But before I do, one comment on why I'm doing this. What I'm particularly interested in here is trying to predict why it is that some people think that men are better leaders. And so I've got to do a couple of things. First of all, I need these collapsed into a single response category that says, no, they don't think that men should be generally better leaders. So I'm going to create a dummy variable where 1 means men think that you're better, 0 are both of these categories. Also, because we're going to be doing statistics, I can't do anything with this 9 down here. That's not going to help me. And so I need to treat that data in a way that will cause SPSS not to analyze it. And so in this case, I'm going to end up creating it to sysmiss. And you might ask yourself, well, why didn't the Pew researchers do that for you? They want to leave these types of decisions about how you handle data up to the individual researcher who's using the data. Let's say, for example, this question instead asked, you generally think of yourself as a Republican. And we had 1, yes, I do. 2 was no, I don't. 9, don't know or refused. Well, people might code this differently. Some people might say, okay, let's treat that don't know or refused as missing data, where other people might come back and say, well, you know what? If the question asks whether or not you're a Republican, if you say you don't know or you don't answer, by golly, you're not really a Republican. So some people might code that if we were doing 1 is a Republican, 0 not. Some people might code that with a 0, where other people are going to say, well, you know, maybe they just didn't want to share their partisanship at all with a stranger, and so they're going to say, because we don't know, let's treat this as missing data. Whatever you do, the cool thing about a syntax file is you're going to have have a notation about why you recoded the way you did, so that when you come back later on and say, why in the world did I treat data in a certain way, at least you're going to have the syntax record of what you did. So let's go ahead and transform the data. We know that it's question 10, so we're going to recode into a different variable, and we're looking for that question 10 down the side. And there it is for us. Let's have a variable that makes sense. I don't know, let's call it male's lead, or male lead. How about that? And because it's a dummy variable, you don't have to do this, but I usually put a 2 after it, reminding me that it had 2 categories. And I'm going to label this variable, thinks males lead make better political leaders. Okay. Old and new values. The whole purpose here is to transform this variable. So if Pew had it as system missing before, I'm going to want system missing now. For our sake, we're going to say that if you didn't know, it for whatever reason didn't answer, I'm not sure what to do or how to treat you. So what I'm going to do is say if you were 9, I also want the system to ignore you when it does statistics. So 9 equals sysmiss. Now I need to collapse those 2 categories, 2 and 3. And there's a variety of ways I could do that. I could do 2 equals 0 over here. I could and then do 3 equals 0 and add it to this. I could do range, 2 through 3 equals 0. So there's a variety of ways that I could do it. However, to make this code useful for me in other ways, I'm going to do this right here. I'm going to say if you were a man, or if you thought that men generally make better political leaders than women before, I'm going to have you treated 1 here. And then I'm going to use the all other values, or else, and that's going to be 0. And the reason why I'm going to do that here is sometimes, as you'll see in the coding, if this was religion, I might say I want 1 through 4 to be Christian religions, and I might say 5 through 17 are non-Christian religions. And so I want to code in a way that's going to allow me a lot of flexibility to use this syntax later on, because I'm going to show you how to use some do some shortcuts once we get out into the syntax. Looks good. I've covered everything. The 1 is going to equal 1 in the new. Everything else equals 0. Notice that I had to do the else after I changed the sysmiss, otherwise it would have turned that 9 to 0. But because I did an order, system miss equals system miss, those 9s were treated as system miss, then we did the 1s, and then once we were done with all of those, everything else I want changed to 0. So I'm going to hit continue. Everything looks good, and I hit change. Now I haven't done anything yet. I haven't asked SPSS to do anything. Now, if I were to hit OK at this moment, what it would do is SPSS would do all of the data for me, and ta-da, I've clicked and pasted, or I've clicked and cut my way through. The problem with that is I'm not going to have any record of what I did in case I want to make some changes. How about this? If I paste it, lo and behold, it's now in my syntax file. And I can go ahead and run it. And there's no problems. It looks good in the output file. This is the same if I had just clicked through. The only difference is by pasting it first and then running it, I've got a record of how I coded the way that I did. Now what I'm going to do is you can label the variables. In this case, we want you to be 1 equals, or rather our response categories. Remember, it's 1 if you think males are better political leaders, 0 if you don't. It's hard, actually, or complicated anyway, more complicated than it should be in SPSS to add value labels. You actually have to go back over to this screen and pop back down here and enter the data here, and boy, really hard to undo that later on. It's a mess. The easiest way to do this is in the syntax file, and so let me show you cutting and pasting from another document that I put together how we do this. Okay, this is separate command language, and what I'm doing here is I've typed this in the first time, but after I do that, I cut and paste it and I change things as appropriate. What I'm doing is I've told already SPSS, hey, can you recode that Pew question 10 having the old sysmiss equaling sysmiss in the new data set. If they said 9, make it system missing in the new variable. If they said 1, that males are better, make it 1 here. And if they said anything else, make it 0. And the new variable that we created was male leader. We had to label that particular variable, and now we're going to add the value labels. Recall that it's 1 if you think that men are generally better, and it's 0 if you think that they're equal or women are better. Common mistake that I make when I'm not paying attention, notice on all of these labels it's 1 parenthesis. Other thing that you need to notice, after you tell SPSS to do something, the last thing in the set of instructions is a period. And then you tell it to go ahead and run, and you do another period. In our case, we've already created the variable, so let's go ahead and put those labels on. Notice here I put the 0 out, or rather the period out here, so I can always see it. And I'm going to go ahead and I'm going to just run that. And here we go. Okay, my output file looks good, meaning that everything ran properly. Just to make sure that we did our labels correctly, we want to do one last thing. I'm going to go up here to Analyze, and I'm going to go to Descriptive Statistics, and I'm going to go to Frequencies. And the new variable that I created is going to be at the bottom. And if I hit OK, it will show me what to do. Who knows? I may want to do a bunch of these all together later on, so what I'm going to do is copy that paste right here, and I could run it, but I'm going to show you one little trick. And this is why we're in syntax. Notice that we've just created a variable that says male leaders are best. Instead of pointing and clicking our way through, why don't we, just for the heck of it, create one that says that women are best, and that will allow us a comparison in a second. Still going to recode question 10. System missing still going to equal system missing. 9 still means that they didn't respond, only in this case, let's make the 2 into 1, because that's what our survey said up here. The 2 was the females. So let's make 2 into 1, else into 0, and we'll just take that female and make it male. You know what? Never make a mistake with a variable, because they all have to be exactly the same. We'll just cut and paste it, and females, women, men. There you go. We stayed in syntax, and now we're going to be able to create a variable that looks just like our other one. So go ahead and run that. No indications that anything went wrong. Notice that because I'm in syntax, if I want to see the frequencies and see how everything looks, I can just add this to the list right here and go ahead and run it. No click through. Let's just see what our frequency distribution is. There's our output. Notice we've got the thinks males are better, females, equal or men, equal men, or equal or women rather, men generally better. Look at that. Our labels all look good, so by running the frequency we were able to see how our labels are going to print out in tables, and everything looks fine. One last point, and then we'll be done with this particular unit. This might be worthwhile as a research topic. Notice that when people were asked whether they think females make, generally speaking, better political leaders, just 6.3% of those who gave a valid response thought that women, generally speaking, make political leaders, compared to 21%. So 1 out of 5 males, 1 out of 20, or rather 1 out of 5 respondents said they thought that men made better leaders. Just a little over 1 out of 20 said they thought women made political leaders. So we can already begin to draw some conclusions. Men are 3 times as, or rather, people were 3 times as likely to say that men make better leaders as they were to say women. We could say, again, 1 out of 20 versus 1 out of 5. Or the other obvious conclusion is the vast majority of Americans don't think that there's a difference based on those two issues. We can see that, you know, something like roughly off the top of my head, 70% or so have no gender preference with respect to leaders. And that is what we do if we're going to want to work in syntax, and we want to be able to see later on exactly what we did. Notice again, we can add notations by putting the asterisks in front, and if we put something right below it, what will happen is it continues to be grayed out. And the other thing that we want to do before we leave is we're going to need to close this file up. We'll save it wherever we opened it from, so our changes are still there. and we'd go ahead and we would close the data set and not save the changes to the data set in case we want to do something later on. For example, we might decide later on, wait a minute, I want to know people who said that men were better. If people refuse to answer it, that's the same as really saying that they don't think men are better. I don't know what the logic of that is, but if you did think that, you know what you might do? You might come back and say, if you refuse to answer it, we're going to go ahead and treat that information or that data as well to put you in the no category. And we rerun that next time we open the data set, and voila, we're going to have a modestly different variable. And so that's why keeping your syntax is so flexible. And that's the basics of recoding data with a couple of examples about how to recode and how you can stay in the syntax and copy and paste much more quickly than you can working your way through the point and click. And more importantly, if you've accidentally miscoded something, you don't have to start all over again. You just simply look at your screen and say, oops, what did I get wrong? And instead of taking 3 minutes or 4 minutes to fix a mistake, you can do it in a matter of seconds.